Hello everyone. In this video, we are going to construct a DFA problem which accepts set of all binary strings which are divisible by 3. So we can solve this problem with the help of remainder concept. So when we divide a number by its divisor, we can always get the remainders from 0 to divisor minus 1. So in this problem, we are going to divide a number by, we are going to check whether the number is divisible by 3 or not. So the divisor is 3. So we can always get the remainders from 0 to 2. For example, if we divide number 6 by 3, we will get remainder 0. So to check the remainder, we can use a mod operation. So 6 mod 3 is 2. 7 mod 3 is 1. If we divide number 7 by 3, we will get the remainder 1. Similarly, 8 mod 3 is 2. 9 mod 3 is again 0. If we divide the next number by 3, we will get remainder 1. So 11 mod 3 is 2, 12 mod 3 is 0. So when we divide a number by 3, we will always get the remainders from 0 to 2. 0 to divisor minus 1. So 0, 1, 2, 0, 1, 2. So it is going on. So to construct a DFA, we need 3 states. One to represent the remainder 0, another one is remainder 1, another one is remainder 2. So we are going to use 3 states. So Q0 for representing remainder 0. Q1 for representing remainder 1, Q2 for representing remainder 2, because we will get only 3 remainders 0, 1, 2, and whenever we get the remainder 0, we can say that the number is divisible by 3. Since 6 is divisible by 3 because we are getting number remainder 0. Similarly, 9 is divided by 3, 12 is divided by 3. So whenever we get the remainder 0, we can say that that number is divided by 3. So we can make Q0 as a final state because Q0 represents the number divisible by 3. So in this problem, Q0 is start state as well as final states. Q1 is representing remainder 1, Q2 for remainder 2. So now we can construct a DFA. Q0 is start state as well as final state. And this is a binary string. So sigma is 0 and 1 input alphabet. So from each state we have to construct transitions for 0 and 1. So in Q0, if the next input is 0, next input is 0 means the remainder is 0 only. 0 mod 3 is 0. So remainder 0 means we need to draw the transition for state Q0. Then from Q0, the input 1 means 1 divided by 3. 1 modulus 3 will give 1, remainder 1. So it goes to Q1. So from Q0, 1 goes to Q1 because we will get the remainder 1. Now in Q1, now we have to consider the current state Q1. So we can reach state Q1 after reading 1 only. So after reading 1, the next input is 0. Assume that the next input is 0. So the decimal equivalent for 1, 0 is 2. So when we perform odd operation for this 2, we will get the remainder 2. So remainder 2 means it should go to Q2. So in Q1, if the next input is 0, we have already read 1. So the next input is 0 means it is 2. So 2 mod 3 will give the remainder 2. So it should go to Q2. So from Q1, 0 goes to Q2. Similarly, we need to consider 1 from Q1. So we have already seen 1. Now the next input is 1. So the decimal equivalent is 3. 3 mod 3 is 0. So it should go to remainder 0. Remainder 0 means it should go to Q0. So from Q1, the input 1 means it should go to Q0. Then we need to consider Q2. So from Q2, 0 is the next input. So Q2 can be reached after reading 1, 0. 1 0 is already we have read. So the next input is 0. So the decimal equivalent for this number is 4. 4 mod 3 is 1. So remainder 1. It gives remainder 1. So from Q2, if 0 is the next input, then definitely it should give it gives the remainder 1. So remainder 1 means then it should go to Q1. So input 0 goes to Q1. Similarly, after reading 1 0, in Q2, if the next input is 1. So it is 5. 5 mod 3 is 2. 2 means Q2. It should go to Q2. So it should remain in the same state for the input Q2. So this is the DFA transition diagram for the binary strings divisible by 3. Now we can check whether a binary string 12 is divisible by 3 or not. 12 means 1100. 1100. Now we have to check whether this input string is accepted by our DFA. This is the number divisible by 3. Binary string divisible by 3. So definitely it should be accepted by our DFA. So now we can check it. 1100. So it is accepted by our DFA. Similarly, we can consider a binary string 1101. So this is the decimal equivalent 13. So it is not divisible by 3. So definitely it should not reach the final state. So 1101. It is ending with Q1. Q1 is not a final state. So it is rejected by our DFA. And when we divide this number by 3, we will get the remainder 1. So we are ending with 1. Similarly, if you consider 14. 14 means 1110. So when we divide this number by 3, we will get the remainder 2. So we will end with Q2. Q2 is also not a final state. So it should also be rejected by our DFA. So 1110. 1110. We will end up with Q2 and it is also rejected by our DFA. So we can construct binary strings divisible by 4, 5 also in this similar way. Thank you.